A natural response the first time you see those Boolean and or operators that are doubled up, 2 ampersands, 2 or bars, is to ask, why? Why do you need 2 of them? And a natural mistake is to only use 1. When you only use 1, you're using a bitwise operator, not a Boolean operator. I've mentioned a couple times when you try to put an integer into an if, it gets converted to true or false. 0 is false, everything else is true. So if I want to do 4 and 1, imagine longer expressions, one of which evaluates to 4 and one of which evaluates to 1. That's true, and that's true. Bitwise operators take the individual numbers, line them up as binary numbers, a series of zeros and ones, and then and or in the case of the not operator, negate, flip the bit by bit. So 4 in binary is 100. 1 in binary is 001. 100 bitwise ANDed with 001. We take the first pair, the topmost bit in each number, 1 and 0, 0. Move down to the middle one, 0 and 0 is 0. And the last one, 0 and 1, still 0. So we get a result of 000, which is false. So 4 and 1 is using a Boolean operator, comes out true. 4 and 1 using the bitwise operator comes out 0, which is false. Completely opposite result. Why would you want it? It's very common to save space and time by packing individual bit values into a single number. If you have some operation which has got 7 different options that you could set, you can take 7 parameters, each of which is just true or false, or you can take a single integer and look at the lowest 7 bits of that integer and see if they're on or off to see whether you want the option on or off. So then, in other words, when someone passes in 4, they're saying that they want the particular option that corresponds to that bit position on and all the other options off. If they pass in 7, that means their number ends 111 in binary. They want those last 3 options on. Nobody works that out in their head and says, "Ooh, I think I'll pass in 13." Instead, they use bitwise and or to combine typically constants that match to those values. So there'll be a constant defined whose value is 4. There'll be another constant defined whose value is 1. Another constant defined whose value is 8. And when you OR them together, you turn on the individual bits in the flag. When you want to test, you bitwise AND to look and see if those bits are on in that flag. Is this a beginner technique? No, it is not. When you're calling those kinds of functions, someone will give you sample code showing that you set the options by passing in the last parameter A, B, C, OR bar, only one of them, D, E, F, OR bar, G, H, I, where those letters represent individual constants. For example, if you're writing a message box call, there's an MB underscore OK and an MB underscore cancel. And if you OR them together, you want both an OK and a cancel button. And the fact that it's bit packed under the covers can be completely hidden from you. If you know the trick, you'll see the single OR bar and go, "Oh, I get it, we're setting bits in an integer," but you don't really need to know. I consider it to be a non-beginner technique. It's really only something I need to mention to keep you from accidentally using it. You're always going to use the double ampersand Boolean and the double OR bar OR for your typical Boolean calculations. In the interest of completeness, I'll also mention the bit shift operators. You've met these in their guise for putting input and output, but they actually existed first in the language as a bit shift technique, where you write the number out in binary and then move all the bits over one direction or the other. Moving all of the bits leftwards is like multiplying the number by 2, because everybody moves up a power of 2, and moving all the bits rightwards is like dividing by a power of 2 and throwing away the remainder, because all the bits move down. Again, not a beginner technique, but if you happen to see people putting these operators with numbers on both sides of them, it's not about writing to the screen or reading from the keyboard. It's about shifting bits around in a packed bit flag. It's almost never what you want to do if you're just getting started in C++. I'm not going to show you a bitwise demo. If you want to play around with these, you're welcome to fire up a console app and put some of these in and see that the examples here on the screen are true, and make some more up of your own if you're interested. Bit twiddling can have tremendous benefit. It can also be tremendous difficulty, and there's some very fiddly, worrisome bits that I don't want to get into, because in general it's not a beginner technique, not something you need to know in order to do effective work in C++ starting from day one.